Alright, so here's our next problem. Now in this problem you have three charges, a 10 microcoulomb, a negative 8 microcoulomb, and a 5 microcoulomb charge, and the distances are all given. And the question is, what is the magnitude and direction of the force on the 5 microcoulomb charge? Okay, so essentially we are interested in this charge here, the 5 microcoulomb charge. Now the method for solving this is going to be very simple and very straightforward. Okay, it involves a lot of steps, but it's going to be straightforward. Basically what we're going to do is we'll find the force on the 5 due to the 10. Okay, find the force, which means we'll find magnitude and direction of that force. Then we'll repeat the process and find the magnitude and direction of the force on the 5 due to the 8. And then once we have those two forces, we know that forces are vector quantities and we can add them using vector algebra. So that's essentially what we're going to do. Okay, so let's proceed. So step 1 is going to be, force on 5 microcoulomb due to the 10 microcoulomb. So this is the first thing we'll do. Now this is going to be, we're going to use our formula. We'll just call this force F1. And first let's figure out the magnitude of the force, and the magnitude is given by K, which is 9 times 10 to the 9 multiplied by 10 times 10 to the minus 6 multiplied by 5 times 10 to the minus 6, and I divide by the distance. Now here keep in mind the distance is between the 5 and the 10, and you see the 5 and the 10 are separated by a distance of 0.4 meters, so it will be 0.4 square. Great, we have our magnitude here, so let's calculate so this value happens to be 2.8125 newtons, and let us also figure out the direction. You see the 10 and the 5 are both positive, so they will repel each other. The 5 will be pushed by the 10, and so the direction of that force is going to be to the right. So we know that F1 is to the right. Okay, let's repeat the process. Find the force between minus 8 and the 5 microcoulomb. Alright, so this is going to be, we'll call this F2. It is going to be equal to 9 times 10 to the 9 times 8 times 10 to the minus 6 times 5 times 10 to the minus 6 divided by 0.15 square. Alright, let's calculate this number. Okay, so this value happens to be 16 newtons. Now let's again figure out the direction of the force. The 8 is negative. Okay, so we have minus 8, which is negative, and the 5 is positive, and the negative attracts the positive, so the 5 will be pulled to the left. So it's going to be to the left. Okay, great. So now that we have our individual forces, let's figure out the net force. So what I'll do is, if we look at the 5 microcoulomb, okay, there is a force pushing it to the right, and the magnitude of that force is 2.8125 newtons, and there is a force pulling it to the left that has a magnitude of 16 newtons. Okay, so now the answer is very simple. The net force is going to be equal to 16 minus 2.8125, okay, which happens to be about 13.1875 newtons, but pointing to the left. Okay, now we could have arrived at the same answer by doing the following step, and this is going to be useful in later stuff. So let's say that when we know F1 has x component 2.8125 and y component 0, F2 on the other hand has x component minus 16 and y component 0, so we can write F net as the sum of F1 and F2, which happens to be 2.8125 minus 16 comma 0 in this case, and which happens to be equal to minus 13.1875 comma 0. And if you were to find the magnitude of this force, you all know magnitude is square root of the x squared plus the y squared. In this case, it happens to be simply 13.1875 newtons pointing to the left. Okay, so make sure that you understand the second process of doing things, because when we have things that are not in straight lines, okay, we're going to have to use our full vector algebra where we have to find components and all those things to figure out the answer. Okay, hope this helps. In the next video we'll move on to that next kind of problem where things will not be in a straight line.